Ahoy! Today, I'm going to show you how to use Unreal Engine and the plugin Twyworks to create avatars that your Twitch chat can customize and interact with while you're streaming. I built a live streaming game environment with a fully featured virtual pit system. People can use channel redeems to dress up, evolve, and compete in races with little slimes, and all of it gets autosaved so they keep their progress over multiple streams. I'm going to show you how to make a simplified version that you can build off of so people in your chat can have a sense of presence in your environment and really feel like they're a part of things. I'm going to show you how to do 4 things. First, we're going to set up Twyworks so that you can use redeems. We're going to create a virtual avatar that gets spawned for every user in chat. We're going to let users change the color of their avatar with a redeem, and then we're going to create an autosave system so that any changes they make to their avatars will persist between streams. Now, just to set some expectations, this tutorial is not going to be teaching you how to make an AI-controlled creature that has a bunch of complicated behavior, like jumping around and eating and evolving and casting spells from a dynamically updated spell book that they went from a racing minigame against other users. We're going to keep the scope a little more narrow for this tutorial. We're going to make a stationary little goober with an owner registered and 1 customizable feature. He's going to be super simple. This is going to focus on the principle of getting Twitch chat to control a thing in your scene and backing up those changes between streams. That's the knowledge that I can offer that isn't already out there in a million other tutorial videos for learning all that other complicated stuff. And the idea is that this will give you a good foundation for creating your own system. Before we get into Unreal Engine, you're going to need to set up a Twitch dev account with your browser. So go to this URL and click on the Your Console button at the upper right. Click on Register Your Application, give it a name, paste this text into auth redirect URLs, choose any category, doesn't really matter, affirm your humanity, and click Create. Now that you have the application, find the Manage button next to it and copy the text that's in the Client ID box. You're going to need that for later, and this is going to be different for you than what's on my screen. For Unreal Engine to communicate with Twitch, you're going to need the plugin Twyworks. You can get it off the Unreal Marketplace for about 25 bucks. Twitch also has its own official API here that you might want to check out, but I've had problems with it responding correctly to redeems, so we're going to stick with Twyworks for this tutorial. The plugins use different functions for connecting to Twitch, but the rest of what we're doing will be about the same with either. So explore Twitch's version if you'd like to try saving money, or check out what features it has if you can get that working. But for now, open up your project in Unreal Engine, go to your plugins, and search for Twyworks, and make sure that's checked. Then go to your project settings, find TwitchWorks on the left-hand side here. It's going to be called TwitchWorks here because the branding is inconsistent, but it's the same plugin. Then you're going to go to Client ID, and inside of this box, you're going to copy and paste the Client ID that you got in your browser on the Twitch dev site. And again, it's going to be different for you than it is for me. And then you want to go to Local Login Port and make sure that 8080 is in the text field. It should be that already, but just double check here. Alright, now we can finally get to some blueprinting. First, we're going to make our Twyworks manager. It's going to connect us to Twitch and keep track of interactions. So add a new blueprint class. You can just make it an actor. We'll call it something like BP underscore Twyworks manager. So drag that onto your map, and then open up the class, go to its event graph, and create a custom event called Connect to Twitch. Right-click on your graph and search for the event we just made to call it. Plug that blue node into the event begin play. Next, we'll define what that event does. So make a branch node and create a new boolean called connect to Twitch. Make it true by default and plug it into the branch. Go to the variable in the tab on the left and click the eyeball to make it public, so you'll be able to turn Twyworks off on your map editor when you don't need it. So go back to the event graph and search for a perform local Twitch login node. It's going to have a pin called credentials. Promote that to a variable and set it to execute from on success. Make sure you use on success and not the blank one above it. It's an easy thing to overlook. Drag off of the credentials node and search for break Twitch login credentials. This will create a node that gives you access to info that we're going to need. and search for a connect to Twitch node, the one that comes with Twyworks, not the one we just made, and have that execute after the credentials are set. Get the username pin from the break node and plug that into the channel pin. Also, plug the credentials variable into the matching spot here. Next, promote the Twitch chat pin to a variable. You're going to need to access this pretty often. And just like before, make sure it executes off of the unsuccessful login pin, not the blank one at the top. And that's all you need to log into Twitch. Next, we're going to define what happens when a message shows up in chat. The Connect to Twitch node has an on message pin on the left. Drag off that and create a custom event for it. Do the same for the on cheer pin. Even if we're not going to use it, Unreal will complain if the on cheer isn't defined. It doesn't need to actually do anything, just make sure it's there. Next, create a custom event called Respond to Twitch Message. Create a new input and search for Twitch message as the type. You can name it the same thing. Set that aside somewhere and right-click on your event graph. Search for the event we just made and call it. And plug it into the onMessage event, and connect the Twitch message pins together. This is a little editor's note. If you ever get a compile error when you call a custom event you just made that has inputs, make sure that you save and compile after adding those inputs. That way the pins will show up correctly when you call it with this blue node here. So now we've got an event that'll happen anytime a message appears in chat. What we're going to do with this is have an avatar spawn into the scene for the person that sent the message. And passing along this message variable will give us information about the user that we can use to customize the avatar. Now before we can finish the rest of this function, we're going to need some more blueprint classes. But since we're still here, let's set up channel redeems first. Search for a bind to onPoints event node, have that execute after setting the Twitch chat variable, and plug that variable into the chat pin. Drag off of the red event pin and create a new custom event, and call it something like onPoints. Create a new custom event that will fire off of here and name it redeems. Add an input to that event, and set it to the type Twitch points event. Set that aside and make a call to it, and plug that into the onPoints event. Now your redeem function is going to have some space, so drag off the points event pin and search for a break node. Then you'll have access to some of the information about the redeem, which we're going to need. Promote the reward ID to a variable, which is going to be a string. This is how Unreal is going to know which redeem is being triggered. Drag off of the message pin and break it. Drag off of the author pin and make a variable called redeem author. This will be the person that does the redeem. Finally, promote the message body pin to a variable and call it something like reward user parameter. This is going to be the text that the user enters when they cash in the redeem, and we're going to use it to let people customize options for their pet. Next, make a call to your respond to Twitch message function and plug the message pin from the break Twitch points event node into it. The respond to Twitch message function is going to either summon someone's pet or create a new one for them. So we want to make sure it's in the scene before the redeem fires off, since the redeem might be the first thing that they ever do in chat. So we want to make sure the pet is there first. Now search for a switch on string node and hook that up to here. Get your reward ID variable and plug it into the selection pin. Add a pin to the switch on string node. Each of these pins is going to execute a different redeem, and the reward ID here is what's going to come in from Twitch to identify which one it triggers. We're going to need to get that ID from Twitch later, but before that, create a custom event and call it change pet body color redeem, or something like that. Add two inputs to it, a Twitch message author type and a string. Name these redeem author and redeem user params. Set that aside, make a call to it, and plug your redeem author and user param variables into it. Don't hook it up to the switch on string yet. We're going to need to get the reward ID it's going to use first, and then name the pin in the switch node, and that'll disconnect it, so you don't need to do that right now. Now create a reward in your Twitch creator dashboard. I'm going to assume you know how to do that already, and make sure that it has text input enabled. So there's a couple of ways you can get this reward ID from Twitch. I put a URL in the description that can get it for you. Just replace the last part of the address with your channel name and keep it open. Then fire off your redeem in your Twitch chat and it'll spit out the reward ID so you can copy it. You can also create a print node in your blueprint and plug your reward ID variable into that, and then if you hit play on your level, it should spit it out in your log and you can copy it from there. So in either case, once you have that ID, go to your switch on string node and replace the pin with that string. Then hook it up to your redeem function. Now it'll fire off any time that redeem is triggered, along with the user and the text that they typed. So we're done with Twyworks for the time being. Next, we need to create a pet class and a pet manager class that can call functions on the pets that belong to the users in the scene. So let's create our pet actor class first. So I'm going to create a new blueprint class. I'm going to make mine a character. I'm going to call it C_pet. So yours doesn't have to be a character class, it can be whatever you want to use to represent your chat as. So the character I'm making and the features that you're going to be able to change are just an example, so just taking the broad strokes of what I'm doing. So I'm going to open that up. So I'm going to add a skeletal mesh and just use assets I already use on my stream. I'm going to make it a little slime guy, and to keep things simple, I'll just give it an idle animation and fix the position a little bit. So we're going to add two variables that can be customized, a user ID to identify who it belongs to, and a body color. This pet is going to be super simple, but learning how to do these two things should give you a good framework for adding your own features. So make a string variable called user ID, and add a linear color variable called body color. To make the body color something that can be changed, we're going to have to make a material instance with a parameter that can be changed on the fly. Go back to your content browser and create a material. Call it something like mPetBody. Right-click on that and make a material instance. Call that something like MIPetBody. Open up the parent material, m_petBody, not the instance. So we're going to keep this material super simple. We're just going to make a color parameter and plug it into base color. While holding down the 3 key on your keyboard, left-click anywhere on the material graph. This will create a vector for RGB and alpha. Now, this is a constant, and we need to make it a variable. So right-click on the yellow part of the node and click Convert to Parameter. Give it a name like Body Color. Whatever you name this, make sure you remember exactly what it is. We're going to need to type this in somewhere later. So now the pet has a material that can change color. Before we go back to the pet blueprint, we need to make a structure for saving its data to a file. Actors only exist while your game is running, and instances of them can't be saved directly between games. So if you spawn an actor, make changes to it, and put that actor into a save file, then close the game, when you start the game back up and load that actor from the save file, it's going to have all of the class default settings. It won't have the changes you made to it during the last game. So to save those changes, we need to record that information into something that can persist into a save file. Then we can recreate the actor from that information. So we're going to use something called a structure to do that. Go back to your content browser, right-click and search under Blueprints for Structure. Name it something like f_pet_saveStruct. This struct is basically going to be a template for building a pet from the information that's in the save file. Any important information about the pet will need a variable in here. So just like in our pet character blueprint, we're going to add variables for the user ID and the body color, and there'll be a string and a linear color just like in the character. Next, we need to make a save file class. Go to your content browser, create a blueprint class, choose Save Game and hit Create. Open that up, make a new variable, make it a map, and call it Pet Archive. For the map key, make it a string, and for the object, make it the pet save struct we created earlier. This will let us use a chatter's user ID to retrieve the struct for their pet in the archive when they type. Now go back to your pet blueprint. We're going to make two functions, one to apply a body color, and one to apply all the information from the save data when it's loaded. So first create a apply body color function. Add a linear color input and call it body color. Grab your body color variable from the left panel and set it to the matching input pin. Drag your skeletal mesh component into the graph, drag off of the pin and search for a set vector parameter value on materials node. Plug the body color pin into the parameter value pin. It'll convert it from a linear color to a vector automatically. This is going to change the material instance's base color. For the parameter name box, go back to the material that you made for your pet body, and note the name that you gave the color parameter, and put that into the text box on your set vector parameter node. Make sure it matches exactly. Now select your skeletal mesh component on the left panel. In the details panel, scroll down to its materials and assign it the mi_pet body material instance. Make sure you use the instance and not the parent material. Now create a function called apply save data params. Give it an input of a pet save structure. Drag off the input pin and break it. This will expose the info in the save data. Create a sequence node and add a few pins to it. Drag your user ID string variable from the left panel and set it to the user ID pin on the break node. This will be the first step of the sequence. Drag your applied body color function onto the same graph and plug the color pin from the break node into it. This will be the second step of the sequence. Finally, search for a return node and plug that into the last part of the sequence. So this function is going to take a brand new default pet, grab all the information that's been written to the save file, and modify the pet to match. The user ID can just have the variable updated, but the body color needs a function to actually change the material. Updating the variable alone isn't going to change the appearance of the pet, and that's kind of easy to overlook, so you want to do both of those steps in a single function. If you ever want to add more customizable features or stats or anything to your pet in the future as your project grows, you can make a function for changing those aspects and add it to this sequence. And that's all the pet blueprint needs to do for now. Next, we need to make an actor that manages all the pets in the scene and applies the user's actions in chat to the appropriate pet that belongs to them. So go back to your content browser and create a new blueprint class. Make it an actor and name it something like Pet Manager. Drag that onto your map, just like your Twyworks manager. This is going to keep track of the pets in the scene and call functions from them. We're also going to have it manage our saving and loading, so pets will retain their info between streams. Before we open that up, I recommend doing an optional step that'll help you down the road. When a message comes in from Twitch, we're going to have the Pet Manager respond to it, but you might also want to have other things react to the same message if you add more systems to your stream in the future. So I recommend creating something called a blueprint interface that any actor in your scene can implement if it needs to respond to messages from Twitch. The actors will all share a function, but that function can behave differently for each actor that implements it. This will simplify things for the Twyworks actor since it can just call one function on everything and it will have less responsibilities outside of communicating with Twitch. So your Twyworks actor won't get more complicated and have to know a bunch of things about all the new things you're adding to your project. If you don't want to bother with interfaces, you can also just have a function called respond to Twitch message in your pet manager and continue from there. So to create an interface, right-click on your content browser, search through blueprints, and find blueprint interface. Give it a name like BPI_Twitch functions. Open that up, create a new function on the right panel, and call it respond to Twitch message. At the bottom right, create a new input, make it of the type Twitch message, and name it the same thing. What the function actually does will be defined in the actors that implement it instead of here. Go back to your content browser and open up your pet manager. Go to the top of the window and find the class settings button. Class default will probably be highlighted in blue for you by default, so click on class settings next to it. That'll change the detail panel on the right. Look near the bottom of that to find the interfaces section. There's a drop-down next to implemented interfaces labeled add. Click on that and search for the BPI_Twyworks functions interface that we just made. You'll need to do this for any actors that need to respond to Twitch messages. This will add the respond to Twitch message function to the interfaces drop-down under the My Blueprint tab on the left. It should be listed under functions and will have a yellow icon next to it. Double-click on that and it'll create a custom event in the event graph for you. Again, if you don't want to bother with interfaces, just add a function to this blueprint and the rest of the instructions will be the same from there. Make sure that the function has a Twitch message input. Drag off of the Twitch message pin and break it. In this break node, drag off of the author pin and break that again. We're going to need the user ID from the message, so expand the node and find that. Now let's make a couple of variables for this class. First, make a string called ScenePets. Make that a map and set the value type to our pet class. This is going to keep track of what pets are in the scene and who they belong to, so we can call users redeem on the right pet. We don't need to make it a pet save struct. Actors can be in a map and retain their changes as long as they don't despawn, so we can use this map to make direct references to them. Next, make a variable for a pet save game class. This is our save file that the pet archive is going to be stored in. What we're going to do next is make a function that decides whether a message from Twitch should spawn a new pet for a new user, or retrieve an existing pet for a user it recognizes. So create a function called createOrRetrievePet, then open that up. We're going to take in a user ID and search our save file to see if there's a matching pet. So give it a string for input and call it user ID. Add a boolean for an output and name it pet found in archive. Add a second output and set the type to our pet save struct. Get the pet save game variable we made in the left panel. Drag off the pin and search for the pet archive map that we're storing in it. Oh, I accidentally made this a map. Let me change that back to just a single item. There we go, now we can do that. Drag off of that map and search for a find node. Plug the user ID input into the pink string pin at the bottom. Finally, plug the red boolean pin into the pet found in archive part of the return node. And plug the blue pin into the pet save struct part on the bottom. Now go back to the event graph, go to the respond to Twitch message event, get our scene pets map, search for a find node, and connect the user ID pin in the break node to it. Create a branch and plug the find node's bool into it, and connect that to the execution line. Drag off of the false pin and call our createOrRetrievePet function. Plug the user ID from the break node into here as well. Then create a branch and plug the pet found in archive bool into that. So what this is doing so far is getting a Twitch message, checking if their pet is already in the scene, and if it isn't, decide whether to retrieve an existing one or create a new one. So next we'll make functions to do those two things. Make a function called createPet, add a string called userID as the input, search for a spawn actor of class node. Next to the purple pin, there's a drop-down box to select the class. Set that to our pet class, not the save struct, just the character. This orange pin will determine the location of where it's going to spawn. For our purposes, I'm just going to set it to a few inches off the ground in the center of our scene, so we can split the structure pin, and I'm just going to add +50 to the Z direction. Drag off of the return value pin, which is going to be our pet, and promote it to a local variable. Drag off of the pin for this node and search for the pet's apply body color function. I'm just going to set the default color for new pets to be green. Now, if you're thinking, hey, I could grab the username color and set the body color to that, that's a great idea. However, the way that Twitch stores the color of a person's username is kind of messed up right now. If the user doesn't set their text color manually and it just gets assigned randomly by Twitch, it will come into Unreal Engine as a busted color. You can try to find a workaround, but I figure that's something you should be aware of. So after applying the color, drag the Scene Pets map into the graph, search for an add node, plug the user ID input into the string pin, and plug our pet local variable into the actor pin. So this will create a new pet in the scene and keep track of them. Next, create a retrieve pet function. Give it an input and set the type to a pet save struct. The first part of the function will be the same as the create pet function we just made. Spawn an actor of the pet class and set it to a local variable. And I'm going to spawn it from the same place. Next, search for the pet's applied save data parameters function you made. Plug in the save struct input into the matching pin here. Also, drag off of the pet save struct and break it to expose the save info. Drag the Scene Pets map onto the graph, search for an add node, and plug in the user ID from the break node and our pet local variable. So this will create a new pet actor, and then make it match the pet that was saved in the archive and keep track of them. Now we can finish up the respond to Twitch message event. Go back to the event graph, plug the retrieve pet function into the true pin of the branch, and plug the create pet into the false one. Connect these two pet save struct pins together, and plug the user ID from the break node into the create function. So this is going to get the user, check to see if it's already in the scene and accounted for, retrieves a save pet if the user has one already, and make a new one if they don't. Now that you have a pet manager actor and a function that responds to a Twitch message, we can go back to the Twyworks actor and tell it to use it. Let's open that back up, add a variable called pet manager, and for the type, search for the pet manager class we just made. Click the eyeball icon and make it public, and then we need to set that variable to the manager that's sitting in our level. So compile the blueprint, go back to the level editor, and select the Twyworks manager. In the details panel to the right, there should be a pet manager actor drop-down menu. Now that Twyworks knows where your pet manager is, go to your Twyworks manager, go to your onMessage event and the event that's connected to it, then right-click on your event graph and find a respond to Twitch message interface. So there'll be several results here, so make sure you pick the one that's from the interface, then plug that in, plug in the Twitch message, and then get your pet manager variable that you set in the level and plug that into the respond to Twitch message interface node. And if you're using an interface, if you ever want to add more systems to your stream, you can just grab whatever actor you use to manage that system and plug it into the respond to Twitch message interface and just make sure that it implements that interface. Okay, now we should have everything we need to create a pet when somebody in your Twitch chat types something. So let's test out what we've got working so far. Start your level up, and you're going to get a pop-up in your browser. And what this is being caused by is Twyworks grabbing your user credentials, and it's using your browser to do that. And this can get kind of annoying, so one way you could bypass this is by saving the user credentials in your Twyworks blueprint somewhere in a save game class, and then load that to bypass the perform local Twitch login node stuff. Keep in mind that if you do something like this, the save data can get out of sync, so if your redeem stopped working all of a sudden, you're going to have to perform a login normally to repopulate those credentials and then load that, and it should work after that. Anyway, once you've got your level running, go in your Twitch chat and type in something to make a pet appear. And you don't have to be actively streaming for this to work. It'll monitor what's going on in your chat even when you're not streaming. So if we type something in, it creates a little guy. And that pet should have our user ID assigned to it, and it's being automatically set to green for the body color. Very cool. Now, when you close it, you're going to get an error that says Unreal can't find the save game the pets are stored in, because we haven't created our saving and loading functions yet, so don't worry about that for now. Now that we're creating a pet from chat, let's add a feature for changing the body color of it with a redeem. We also need to make a function that takes the redeem from Twitch and uses it to change the pet's body color. So let's make that now. Create a function called change pet body color. Create two inputs. Change the type of one of them to be Twitch message author and call that redeem author. This is going to be the person doing the redeem, and set the second input to be a string and call that reward user param. This is going to be the text that the person puts into the redeem text field. Break the redeem author pin. Expand that and promote the user ID to be a local variable for this function. This is so we can connect this redeem to the correct pet that's in the scene. Next, we need to create a function that takes in a string that the user types and turn it into a color that Unreal Engine can use. So create a new function called parseString for linear color. We're going to keep this one kind of simple and just have the user type 3 numbers for the red, green, and blue channel values. So give it an input type of a string, search for a parseIntoArray node, and plug the string input into the source string pin. And you won't be able to see this on my screen, but make sure you type a space into the delimiter box here. So instead of using an underscore like this, make that a space. This is what Unreal Engine is going to use to separate the numbers when it reads the string. Drag off of the return value and search for get a copy to get the first, second, and third indices of that array. Oh, this is some more bad editing. I put 3 in the last node here. Make sure it's 2, because it's an array that starts at 0. So it's not going to be 1, 2, 3. It's going to be 0, 1, and 2. Then create a isNumeric node for each of these to make sure that the string is a number. Plug all of these into an AND bool node and connect that to a branch. You're going to need to add an extra pin so that you can plug 3 into it. Then create 2 return nodes. For the return value, you're going to want to return a boolean called isValidColor and one for a linear color. Then set the isValidColor on one of the return nodes to true by hitting the checkbox, plug that into the true branch, and then plug the other one into the false branch. Then create 3 division nodes, and set the bottom pin to be a float. And enter the number 255 into the bottom pin for all of them. And plug the strings from the get nodes into the top pin of each of those. Then search for a make linear color node. Plug the top one into R for red, plug the second one into G for green, and plug the third one into B for blue. And you can keep alpha as 0. Then take the linear color pin and connect that to the true return node that you made. Now, this is a pretty cheap way of getting color from a user. If you would like something a bit more robust, I put a link in the description to a function library that I created that can take in other things like hex values and color names and automatically parse what system the user is trying to use to change the color of their pet. So if you need something like that, you can go ahead and migrate that into your project. Make a call to your parseString for linear color function that we just made. Connect the string pin to the reward user parameter pin for your input, and then create a branch node and plug the isValidColor bool into that. Then grab your ScenePetsMap variable, search for a find node, plug the user ID that you got from breaking the Twitch message author, and plug that into the string to find the correct pet. Then create another branch and connect that to the true pin of the previous branch, because we only want to perform this function if the user inputted something that can be interpreted as a valid color. And so plug the second one into the find node so that we do this if we find the correct pet. Then drag off of the pet actor pin on the find node and search for the apply body color function that you made for it, and then plug that into the true branch here. And then grab the linear color from your parseString for linear color function and plug that into the apply body color function. So this is going to take the Twitch author, take what they typed in, parse it to get a usable color out of it, and if it is valid, it finds their pet in the scene, and it applies the body color that it got from our string parsing to the pet that it found. Okay, now we need to plug this function into Twyworks so it fires off when a user does the redeem. So open up your Twyworks Manager blueprint, and we'll go over to our redeem. We're going to grab our pet manager variable, and we're going to call change pet body color. We're going to plug that into this event, and then we're going to plug author into redeem author, and plug redeem user param into redeem user param. And now our pet manager function should fire off when the person does the redeem. All right, now that we've done all that, let's test out the color change redeem in our chat. So start your level up, go into your Twitch chat, and choose the redeem, and type in 3 number values for RGB. I'm going to do 25500, and there we go, we changed our slime to red. So our final step is going to make it so that when we close the game, start it back up, and summon the pet again, it will come in with that red color that we set it to automatically. So in order to do that, we're going to have to create a saving and loading system in our pet manager blueprint. So go back to your pet manager blueprint, and we need to create a function for exporting a pet to a save struct, and one that goes through all the pets that are in the scene and perform that function on them. So first, create an export pet to save struct function. Add a pet as the input. Make sure it's the pet class and not the save structure class. Next, we'll add an output and make that the save structure class. And search for the user ID and the body color variables. Right-click on the graph and search for a make f_pet save struct node, or whatever you called your save struct class. And plug the 2 variables that you got from the input into the matching pins. This is going to take the information that a save struct needs and create a struct from those things. And then drag that struct into the return node. So this is going to export a single pet. Create another function called send pets to archive. This one's not going to need any inputs or outputs. So get your scene pets variable, the map that we're storing the current pets in. Drag off of it and search for a is not empty node. Make a branch and plug the bool pin into that. What we're doing here is skipping the save function if there aren't any pets in the scene yet. Drag off of the scene pets map again and search for a keys node. Plug that into the true pin. Right-click on the graph and search for a for each loop node. Plug the array pin from the keys node into it. Then drag off of the scene pets map again and search for a find node. Plug the array element pin from the for each loop into the find node. Then create a branch, connect the branch to the loop body, and plug the find bool into that. Drag off of the actor pin in the find node and search for the export pet to save struct function we just made, and plug that into the true pin of the branch. Get your pet save game object variable, and get the pet archive that's stored in it. Drag off of that map and search for an add node. Connect these 2 save struct pins, and then connect the string pin to the matching one that's in the for each loop. Go back to the event graph and create a new custom event called Start Autosave. Then search for a Set Timer by Event node. Drag off of the red event pin and create another custom event and call this one Save. This timer node is going to fire off your save function to whatever you set this time value to, and the format is in seconds. Also make sure that the looping box is checked. Make a call to your send pets to archive function, and then search for a save game to slot node. Get your pet save game variable, and plug it into the save game object pin. and then promote the other 2 pins in the node to variables. Then create another custom event and call it load. Search for a does save game exist node. Then grab the slot name and user index variables you just promoted and plug them into this node. Make a branch and plug the bool from this node into that. From the false pin, search for a create save game object node. Set the save game class drop down to the pet save game class that you created. Then set your pet save game variable to this node's return value. Search for a save game to slot node. Connect the save game pin into the save game object pin, and then once again grab your promoted slot name and user index variables into the matching pins. Go back to the previous branch and create a async load game from slot node. Get your promoted slot name and index variables and plug them into here too. Then create another branch and connect it to the completed pin. Make sure it's the completed one and not the blank one up here. And then plug the success bool into that. Drag off of the save game pin and search for a cast2 pet save game node, or whatever you called your class, and make that connected to the true pin of the branch. Grab your pet save game variable and set it to the as pin of this cast node. And make sure it's connected to the top pin here if it's successful. Okay, here's the last step. Go to event begin play, or create a new one if you've deleted it. Call the load event that you just made, and then call your start autosave event. This will first attempt to load a save game if there is one, create a new one if there isn't, and then start the autosave timer. Alright, now everything should finally be working, so let's test it out. So start your level back up, go into your Twitch chat, summon your pet by typing in chat, and then use the change body color redeem, and we'll make them red again. And then after the autosave kicks in, we'll close it, and then we'll start it back up, and we'll type in chat again, and there we go! It automatically retrieved our boy, and with all the changes that we made to them. Very nice. Now, I know that was kind of an assload of work to get that one little thing to happen, but the way that we built it should be a good modular foundation for adding new features in the future while minimizing spaghetti code. If you ever need to add a new feature to your pet, what you can do is add any necessary variables to the save structure for the class, give the pet a function for changing those things, and then add whatever that function does to your apply save data param sequence. Then make your redeem in Twitch and add that ID to the switch on string node and call it from there. There's a lot of really cool interactive experiences that game developers, streamers like me are creating, and I hope that this tutorial helps you come up with your own ways to make even more cool and innovative stuff to contribute to this weird little phenomenon that's been building. If you have a project that you're excited to work on and you need to brainstorm on how to make that happen, please let me know in the comments section, and I hope what I've provided so far helps get you started. Bye!